Started recording. I hope it's okay with everyone. Okay, so I'm going to talk about the three things actually: Bayes' rule, the scientific method, and machine learning. and all of that is going to be done in the context of just a simple riddle. So the riddle is as follows: you have three cards, one which are have the color white on both sides. So here, Ryan, you see this is the letter Lamed for white. So you have this one represents here the card that has white on both sides, and then there is a card that has red on both sides. So you see this is the letter Aleph, and this represents a card that has red on both sides. And then there's a card that has red on one side and white on the other side. And what we're going to do, so we have these three cards, we're going to put them in a bag and randomly pick one of them. So on the left here, this column represents the card that I randomly picked. So here I picked a card that is red on one side and white on the other side. And here, for instance, I picked a card that is white on both sides. Okay? And then once I pick a card randomly from a bag, I randomly choose to put it on one of its sides. Okay? So here I've chosen the red to be on the top, on the visible side, and the white to be on the invisible side. Okay? If both sides are red, like in this line, it doesn't matter, right? I flip it and randomly choose one of the sides, but it doesn't matter because in both cases I would see a red on the top. But if one side is red and the other side is white, when I flip it, when I randomly flip it, I would see either red on top or white on top. So the first thing I want to ask is, what's the probability that I'm going to get a red on top and a white on the bottom? So the red is visible, but the white is on the other side. What's the probability of that?
%, right?
How much?
Third.
No, that's not correct. Because think about the process. So I'm picking a card from the bag. That's 1/3. Okay. But then I'm flipping the card to either put one side or the other side at the top, which is a half. So the correct answer is 1/6. Okay, is that clear? Yes, no?
So you mean the probability to get either red or white, one of the cards that is...
No. I meant the probability of getting a red at the top and a white at the bottom.
So yeah, now it is clear.
Yeah. Yeah. So I'm going down the path that you are thinking about. So what's the probability of getting a red at the top and a white at the bottom? So sorry, what's the probability? Sorry, erase that. what's the probability of getting a red at the top and a red at the bottom? What's the probability of that?
Third.
Yeah, correct, because it's these two lines here, right? There's two cases in which we choose a red at the top and a red at the bottom, because we choose the right card, which is 1/3, and then we flip it, which is 1/2, but it doesn't. So there's two cases. For us, what we see is the same, but it's actually two cases. So it's 1/6 plus 1/6. So it's 2/3. It's 1/3. Sorry, 2/6, 1/3. Okay. So we have 6 cases here. Each one of them has a probability of 1/6. And okay, so the classical riddle is, what's the probability of given a red at the top that there's a white at the bottom? Okay, so the conditional probability of, so R is, so we have two random variables here. One is R, which is, we see a red at the top, and OR is the other side is red. Okay, so let's see what's the probability of, given that we see a red at the top, the other side is red. And let's do it by enumeration first. So I don't want to use Bayes' rule yet. I want to just do it by enumeration. So let's see, how many cases do we have that we see a red at the top? At the top. So yes, so this is this case, and this case. Case 1, case 3, and case 4. So there are 3 cases in which we have a red at the top. And how many cases would have a red at the bottom? So we have case number 3 and case number 4. So that the probability of having a red at the bottom once you have a red at the top is 2/3, and the other one is 1/3. Is that clear up to now?
Yes.
Great. Now, let me make a general comment about this. So historically, probability theory existed before the idea of a sigma algebra. So before the idea of a set of a set of events, okay? So people would calculate these probabilities without this enumeration, which led to a lot of confusion about probability. So the contribution of Kolmogorov of introducing axiomatic probability theory and the sigma algebra, one of the contributions is actually to think about the problem in this way. So I need to enumerate all the elementary events, and then in this case, because it's finite, all possible subsets are in the sigma algebra, and we have, there are possible events, and we have probability for all of them. So that's one comment. The other comment is, note that I'm describing the events I'm interested in using random variables and their combinations. So one interesting comment by Laplace was that you need to write all the variables and their probabilities, and then you can reason about reality. Not in these words, but something similar. Okay, so really the scientific method starts with enumeration, with thinking about an elementary space and the events that are possible in that you are interested in, that are possible and you're interested in. Events are subsets of a set. And then enumerating them using some variables and conditions over the variables. And if you think about it in that way, then Bayes' rule is a way to update your intuition about the reality based on something that you've seen. So essentially, the riddle of the puzzle here is an instance of the usage of the scientific method. I've seen that that red is on the top. What do I think now about red on the bottom? What's the probability of the red at the bottom? Okay. So one can think about Bayes' rule as an instance of the scientific methodology. If you think about probability theory as a Bayesian, assuming you have enumerated, you've described the space of possible events, and you define the variables that you're interested in and the conditions that you're interested in. So now someone I've ran an experiment. I've seen that red is at the top. Now I want to reason about something I don't see. What is on the bottom? So it's an instance of the scientific. It's a generalization of the scientific method, the Bayes rule. Now let's see if the Bayes rule here works. Okay, we'll check if it works by enumerating everything. Okay, so let's see. One of the ways to think about the Bayes rule is that we can factorize the event of R happening and OR happening together, intersection. So one way of factoring it is to assume that R happened first, and then assuming that R happened, OR happened. And another way is to assume that OR happened, and assuming that OR happened, R. So this is two possible factorization that both represent the case that both OR happened and R happened, so they represent equality. So that's one way of thinking about the Bayes rule. So let's have a look here and see what are these different probabilities. So we've seen that given that the top is red, the probability that the other side is not red or the other side is red, the probability that the other side is red is 2/3. Okay, we've seen that. Now, what's the probability that R is red? So this is line 1, 2, and 3. So it's 3/6. what's the probability that OR, that the other side is red? So this is first line, second line. So yes, so probability that the other side is red, it's first line, line before the last, line number 5, and the last line. So it's 3/6. Now, what's the probability that, given that the other side is red, the side we are looking at is red, so that occurs in the case of, so the other side is red, is cases, is second line, third line, fourth line. Out of them, third line and fourth line are the cases where the other side is red. So this is 3/3 and 2/3, and we see that these two are equal. So basically, we see that we can update our, if we use the probability of the other side being red, the probability of this side being red, and the probability that if the other side is red, this side is red, we can update our estimation of the other side being red, given that we see that this side is red. So this is the Bayes rule in the scientific method. How is that connected to machine learning? Well, the connection I'm thinking about now is the connection of being able to update my probability estimation about something, given new data that I see. Okay, so basically applying the Bayes rule. And in subsequent meetings, we'll talk about that in more details and talk about Bayesian networks. So any more questions or comments about this? Okay. Okay, so thank you very much for joining today, and we'll continue next time.
All right, thanks, Eitan.
Thank you, Eitan.
Thank you. Bye-bye.